Cool. All right. Thank you for coming, everybody. Welcome to our Git workshop, which has been, cleverly named Git Good. So I understand a lot of people here have done Comp 1531 or are doing Comp 1531, and I know a lot of you have probably touched upon Git in the last couple of weeks. So for a lot of you, this is probably going to be a little bit of sort of revision. How does this sound? Ooh. Can everyone hear me? Okay, I'm going to arch down a little bit, so bear with me. But I'm aware that a lot of you are doing Comp 1531, so this might be a little bit of revision for you, but hopefully we'll be able to go into a little bit more of the details about how Git works, and we can all come away having learned something new. So, the first question is, what is Git? So we know Git as a version control system in comparison to things like Mercurial and stuff like that and SVN. But in particular, Git is a distributed version control system. So when we say distributed, what we mean is that there isn't any real central sort of server or repository for our code. So what I mean by this is, imagine you're working on a project and you've got a bunch of friends who are also working on the same project, and you have your code and your friends kind of have their own code, and they're all kind of different from each other, right? You know, this guy up on the top left might be working on adding a new button to your user interface. You might be working on adding some new backend code. Old mate on the right might be working on some new API function. The point is, everyone's working on something different, and you want to be able to consolidate all of your efforts into building one product without having conflicts. So what we can do with Git is we can pull changes from someone else. So our friend on the left has given us their code containing whatever they were working on, and we can push changes to other repositories so that they get our changes. They get our copy of the repository in a sense. So this is kind of the essence of Git. It's that you can push and pull changes in between the people that you're working with in order to manage your versions correctly. Now, the reality is that when you're using Git, you've probably used it with like a central server. If you've used things like GitHub, GitLab, or if you've used the UNSW servers as a Git server yourself, this is still distributed because in reality, the Git server that you're working with is no different from any other Git client. If you wanted to, you could push and pull changes to your friends' laptops if they let you. So the point of this being a distributed version control system is that there's no central server, but the reality, of course, is that we're kind of going to use it in a centralized way anyway. So, whoops. Come on, cooperate. So the first thing is that Git is a command line tool. So a lot of people have probably seen things like source tree or the Git GUI that you can get on the Git website. I kind of recommend that you avoid using this when you're first learning Git, because ultimately those GUIs are just sort of front ends to the underlying Git program. And the best way to learn is to kind of dive in and do it the hard way. So whilst you're learning, I'd kind of recommend that you shy away from the GUIs like source tree and Git GUI, just to make it sort of easier on yourself when you're learning. Initially, it'll be harder, but ultimately, the principles that you learn when you're using the command line tool will apply when you're using the GUI as well. So let's get into some of the specifics of what it's like to actually use Git. So we're going to go through sort of the golden 6 commands, and these are the 6 commands that you're pretty much going to use 99% of the time you're using Git. Most of the time, these will probably be the only commands that you use, and these will pretty much make up the bulk of your work with Git, unless you sort of do something wrong, or you want to do something a little bit exotic, or if you've got sort of a setup that is a little bit more unusual than what we're normally used to. So the 6 commands are git clone, git add, git commit, git push, git pull, and git status. And like I said, unless you're doing something really exotic, this will probably be what you need for pretty much everything that you do. So the first command is git clone, which copies a remote repository into your local directory. So if we go back for a second to this slide here, so normally when we're talking about our remote repository, we're actually talking about like our central server, like our Git server, which might be GitHub or GitLab or whatever. But in reality, because Git is a distributed version control system, you can Git clone from really anyone you want, right? If you have your friend, you can Git clone from their laptop to copy from their local repository, right? So Git clone basically lets us take the repository that's sort of resident somewhere else, and it copies it to our laptop so that we can start actually working on it as if we're any other developer, right? So we're kind of joining this little network of Git peers, so to speak. So generally speaking, when you're going to do Git clone, you're going to be cloning from a central repository. So if we've got our Git server up there, which might be GitHub or something, and we've got a repository of code there that we want to clone so that we can start working on it, Git clone is the first thing we're going to do. So imagine our file system is like, it's empty, we don't have anything there, and we want to clone the code that's sort of resident on that server. We've got our repository, which contains all of our code base, and we've got the Git server, which might be hosting like multiple repositories. So something like GitHub has thousands, if not hundreds of thousands of different Git repositories that you can clone from. So when we do Git clone, we can specify using SSH or HTTPS. Here I've given the example where we're using SSH. Basically, it's two different ways of actually transmitting the repository to your local device. And you can see after we perform Git clone, we have the repository, we have its full history resident on our device. So that's Git clone. This will probably be the first step that you do whenever you are working with a Git repository. So let's do just a quick demo. So I have like a test repository here, which is over here. So this is just set up on GitHub. Pretty straightforward to set up. This is a private repository. Something I'm sure they've said to you a million times is that when you're doing your assignments, which is probably going to be the bulk of what you're doing on Git for the moment, you always want to have your repository set to private. And to do that, you can get GitHub's, they've got like a student plan that you can sign up for. I don't have the link on me, but if you look it up, you'll find it on the GitHub website. This will give you free unlimited repositories for the duration that you're a student, which is really, really important for when you're doing your assignments. So this is a demo repository. All it contains is a README. So this markdown file here uses GitHub's markdown syntax, and it's good practice to have a README in all of your Git repositories so that people who come to your repository, if it's a public repository, will know what this repository is all about. And you can include things like setup instructions, best practices when you're contributing, that sort of thing. Of course, our README just says this is a demo repository. So the point is we've got one file in this repository right now, and I want to get all of those files onto my local device. So I have set up my little directory here. You can see there's nothing in it. And I'm going to do Git clone, and I'm going to this is the Git repositories URL. And now that's going to get the entire repository and all of its history into my local device, okay? And it's going to clone it, and it's going to ask for my username. It's going to clone it into the current working directory. So you can see we've now got demo repository. Okay. Now, what your Git repository actually is doing, and the reason why we have all of this information, like for example, you can see that I'm actually on the master branch. The way that our shell knows this is because Git actually creates a hidden file when we make a repository, which is this .git file, okay? Can everyone see that? Can anyone not see it? Okay, cool. So this repository is essentially the heart of your Git repository, okay? So this folder is the heart of your Git repository. You can think of this as the nuts and bolts of Git under the hood. And this is really contains all of the things like version history, branches, what the current head commit is, that sort of thing. So maintaining the sort of cleanliness of this directory is kind of, if you mess up this directory, you won't have a Git repository anymore is the point I'm making. And just to demo that. Okay, it actually doesn't even want to remove it. And now you can see the little prompt that used to be next to my my shell that said master is now gone because this isn't a Git repository anymore because I've just deleted all of the information about the repo. I still have the files, but now that I've gotten rid of that directory, no Git repo. So that's what that file is. I'll actually not do that. Okay. So that's git clone. That's how we get a repository on our computer from somewhere remote. So the first command that we're going to go through is git add. So what this does is this adds files to your index. So the index is kind of like your list of changes that you've made, as well as all of the files that are currently in the repository. So a common misconception about Git is that it only saves like the differences between one version to the next. In fact, it actually saves the entire working file tree in each commit. That may not mean a lot now if you're not familiar with Git, but I'll go into it. The point is the index will contain all of the files that are currently in the repository. And when we use git add, what we're doing is we are adding files to that index, which is just a directory that contains all of the files that we're going to be putting into our next commit. Okay? And a commit is like a version. So what this literally is like the index is kind of like our staging area for changes. So whenever we're performing work, what we're going to do is we're going to make a bunch of changes. We're going to git add all of those changes to put those changes into the index. And then we're going to make a version out of all of these changes that we've made, okay? So essentially, yeah, the index is a staging area. So if your repository looks like this, you have three files. You've got a file.txt, rm-file.txt, and unchanged file.txt, and that's the contents of those files. And we start messing around with the index by using git add. The index will initially look like this. So again, common misconception is that Git only saves the differences from one version to the next. But in fact, the index will by default contain all of the files in your Git repository, okay? So initially, the index just contains everything that's currently in your repo. And let's say we make some changes. We add a line to our first file, and we leave the other file unchanged, okay? So now our local files, or like our local, I think the term is like the working directory. Your working directory is now different from the index, okay? And so if we want to add those changes and make sure that we can actually add them to our next commit, we have to use git add. So when we go ahead and use git add, this is what's going to happen. So you can see a file.txt is overwritten with the new version of the file that we've changed. And now that's part of our index, okay? So there are different ways. If you wanted to remove something from the index, you can do git, how do I do it again? Git rm -- cached, and then type the name of the file, and that'll remove it from the index altogether. Whereas git rm will actually straight out remove it from your working tree and the index. Okay, but you shouldn't really need to remove stuff from the index too much. So the point is that when you make changes, you add them to the index, you're overwriting the version of the files in the index with your new changes. So if we go ahead and we make a completely new file, and we remove the file called rm-file.txt altogether, our index remains the same. And then when we do git add and we add those files, we're going to remove rm-file altogether, as you can see, and we're going to add new file to our index, okay? So if we were to make a commit and push this and have someone clone the repository, their files would look like what's in the index, okay? If that doesn't make sense, it will make sense when I go through git commit. So the point is, our workflow is going to be, we're going to make changes, add files to the index, and then make a commit. So I'll demo that as well, and you can get an idea of what the workflow looks like with Git. So we're going to make a new file. So we've now got, whoops. So we've now got a new file in our directory, and if we do git status, which is going to show us the status of our working tree and also the index, we can see that we have an untracked file. So an untracked file means that you have a file that is not in the index and that has never been in the working tree before, okay? So in other words, it's a file that Git simply doesn't know about. So if we go ahead and do git add new file, so we can now see that we have some changes to be committed, right? So everything that appears in the green there is a new file that's now in our index, okay? So if that's kind of pretty much the gist of using git add. So now is where we sort of get into the actual sort of version control of Git, which is where we make a git commit, which is making a new version of your repository that you are now going to sort of upload to the central repository so that other people can use it, okay? So when we use git commit, what we're doing is we're making a completely new version, and Git is going to save everything in the index, and it's going to turn that into a commit that's identified by a hash and a parent. So this is going a little bit under the hood of how git commit works. So imagine for a second that our index kind of looks like this. So what we've done is I've kind of put rm file in red there to show that we've removed it, but just pretend for a second that it's not there because we've deleted it altogether, right? So if our index looks like this, where we've got a file and a new file in our index and we've removed another file, and we go ahead and we do git commit -m, and -m stands for message. If you just do git commit, it'll open up and it'll prompt you to write a message. What's going to happen is that we're going to get the index is kind of like now sort of saved in this state now, and we get a commit. So you may have seen when you're working with Git, you're going to have a hash which represents uniquely which commit this is, and it's going to have a message. Okay, so the hash should be completely unique for all the commits. Git will automatically generate one for you whenever you make a new commit, and that hash can be used whenever you need to operate on a branch. Whenever you need to operate on a commit, you can use that commit's hash to uniquely identify which commit that is. And again, a commit is the entire state of the index at the time the commit was created, okay? So that is what git commit does. It creates a commit, which is a revision for you. Yeah.
Does every commit have to have a message?
You can leave an empty message if you wanted to. It is best practice to include a message that describes generally what you did in the commit. A message is not mandatory. You can have a commit that doesn't have a message. But the whole philosophy is Git that you want your commits to not just be a list of versions, but you want them to also be almost a history of the code that you're working on. And so you want it to be like, I can go through and look at all the commits, I can read all the messages, and I can understand what changes have been made to this code base over time. Also, if anyone else has any questions, please just raise your hand and like, or jump in or whatever. I hope that kind of makes sense. So essentially what we're going to have is we're going to have almost like this stream of commits, or this hierarchy of commits, where each commit is a representation of the index at the time we made the commit, and it consists of all of the files in the index at that time. It consists of a hash, which is our unique identifier for that commit, a message, which again, we kind of really should have. We don't have to have it, but we should have a message, and 0 or more parent commits. So in this instance, each line represents like a parent-child relationship between a commit. So for example, I'm going to walk over here for a sec. For example, this commit is the parent of this commit because it precedes that commit in the Git history. And I say 0 or more parent commits. So an example when you're going to have a commit that doesn't have a parent is going to be your first commit. So when you make your first commit, that commit doesn't have like a predecessor. It's the initial commit. So that commit has 0 parents. Whereas if you're working in a completely linear fashion like this, so you're making changes, you make a commit, you make some more changes, you git add them, you make a commit, so on and so forth. Your commits are all going to have one parent, basically. So the parent is kind of like the predecessor of that commit. So we'll see an example where we can have a commit with multiple parents, but we'll get into that when we start going into pushing and pulling and merging and things like that. So the long and short of it is a commit has all of the files in the index at the time it was made, a unique hash, which you can use to refer to it in future operations, a message, which should be a description of what you did or what changes you made, and 0 or more parents. And parents are stored as like the hash of the commits that are that commit's parents. So say we've got a bunch of commits, right? We've been working away, we're working on our code, we've made a bunch of changes, and now we have a whole bunch of stuff that we want to send to our friends, right? So going back a second to what I said about this being a distributed version control system, you can push your commits to your friend's laptop if you want to. But generally speaking, I'm going to be thinking in sort of like the centralized Git kind of pattern, where you've got GitHub up here and you've got all your friends down here, and you're all sort of pushing to this central repository and then pulling from the repository rather than from each other. But you can still think of Git push and Git pull in terms of pushing to someone else's device if you wanted to. And there may be instances where you might want to do that. I've done it once in my life, but I don't know, it might come up. So Git push takes all of the commits that you have made, and it's going to send them somewhere else, whether it's a central repository or someone else's computer or what have you. So pretend for a second we have made our change, and the hierarchy of Git commits is kind of like linear in both the remote repository and on your local repository. So basically what we've done is we've cloned the remote repository, we've gotten its full history, right? So your head commit, which is the current commit that you are currently on, is going to be pointing to the end of the remote repositories branch. And I've made some changes. I've done git add, I've done git commit, and now I have a new revision that I want to give to someone else. This is the scenario we're in. So the green commit is our new commit. So when we do git push, what we're going to do is we're going to send those commits to the remote repository, okay? So now the remote repository contains our changes, and if someone else wants to push, they have to get all of those changes somehow from the remote repository and sort of put them in their own repository so that they can make their changes on top of that, okay? I hope that kind of makes sense to everyone. So git push is just, I'm sending my commits somewhere else, okay? And again, if you've made a commit, that's the full file hierarchy, and you're sending that over remotely. So let's get a quick demo going. So at the moment, this is kind of our blank repository again. So remember, I have made my commit, but I haven't pushed it. Actually, I haven't even made a commit. I've just added some stuff to the index, right? So what I've got here is I have my new file, and if I do git status, I can see that I have my branch is up to date with origin/master. So origin refers to the sort of like the remote repository. And so origin/master is the master branch of the remote repository that I'm talking about, okay? So in our case, origin is going to be this repository here on GitHub, and I've cloned that repository to my own laptop. So at the moment, my branch is up to date with origin/master, and I have some changes that I've put into the index. So what I'm going to do is I'm going to do git commit -m. I'm going to say, I made a new file, right? So now we can see I've got master 8A4E47C. That's like an abbreviation of the hash of the commit that I just made. And it tells us the message for the commit. And it tells us what we've changed and that we've created like a new file and everything, right? So if I now run git status, I can see that I'm on branch master. My branch is ahead of origin/master by 1 commit. And I can publish my local commits by pushing, right? And it says nothing to commit, working tree clean. That's saying that my working tree, which is my local files, isn't any different from the index, okay? So basically you can imagine that as our index and our local files are the same, so we're up to date, right? Now that I've made a commit, you can see the commit hasn't been pushed, so I still have only 1 commit, and it's still just the initial commit. But if I now go git push and type in my credentials, So this is kind of where the perception that Git only stores the deltas between different commits. So Git will perform delta compression in sending the commits to the server, but the full files are still available. So to explain this output, we have got 3 changes. We've compressed those changes, we've sent them to the Git repository, and now the master branch is now pointing to somewhere else. So it's pointing to a new commit, okay? So you can see here, if I refresh, my new file has appeared because I've published my commits and they're now in our central repository, all right? So git push is for when you've made changes. Oh yeah.
Is there a reason why the add and commit are functions? Because
Yeah.
wouldn't it just make sense to just say commit message and just keep updating changes?
Yeah, so there are two things I want to say about that. So firstly, the use case that you're describing is where I've made all my changes and like I'm ready to go, right? And I just want to like add and commit all of the changes that I've made. The reason they're different is because I might change my mind, right? I might make a new file and I'm about to commit and I think, oh, actually, I want to actually make a new file and add some more stuff to that. I want to make further changes. So then we can, if they were one command, we would have already made our commit, right? But because they're two commands, we can just keep Git adding different files to our pending commit, right? Another thing is that you actually can Git add and Git commit in one command. I don't normally want to do this because I'll show you what I mean. Oops. So if we run git commit -a, what we're going to do is we're going to automatically git add all of the changed files in our repository and all of the untracked files, and we're going to make a commit out of them. So if you wanted to, you can do it in one command. The reason I don't necessarily like to do this is because if I just try to add a whole bunch of files at once, right, there might be files there that I don't really want, like binaries and stuff like that. Best practice is when you're making a new version, when you're making a new commit, you want to exclude things like your personal configuration. You want to exclude things like binaries that are going to be built anyway. You really want to sort of keep your Git repository as just code and configuration. No binaries, no libraries, nothing like that. So the reason you might not want to do this is because you will find that you accidentally add files that you didn't want in your commit. So in fact, I'll kind of showcase that. So I made another file, right? And if I go git status, you can see I'm up to date with branch origin master, and I've got some untracked files because I added this new file. So if I go git commit -am, more files, git status. Well, what have I done? Maybe I'm wrong. Let's type something. Okay. I may have misremembered how git commit -a works. Or maybe they removed it actually. Whatever. Let's move on from that. So let's say for a second that someone else has made changes to our remote repository, and I now want to get their changes from their remote repository and move them into mine. So basically imagine that you and your friend are working independently, and your friend has just like made a bunch of changes and then they've pushed them, and now you need to get up to date with the work that they've just done. So git pull will take the commits in your remote repo, and it's going to copy them over into your repository, right? And you might imagine that there might be some problems with this, because for example, if you and your friend are working on the same file, and you've both got commits that conflict with each other, then you need to be able to somehow resolve that, right? So Git can largely do this automatically, but sometimes you will make changes to files in a way that can't be reconciled automatically, and you need to actually choose which particular modifications you want to include in your merge. Okay, so git pull lets us update our local files and retrieve commits from a remote repository. So imagine for a second we are kind of in the situation where we were before, where we have this list of commits. So you can see the sort of like the gray ones and the green ones are the same between your repository and the remote repository. And someone has pushed a new commit, which is this yellow one, to the remote repository that you don't have, okay? So bear in mind that, sort of have in the back of your mind that you could add more commits sort of independent from changes to the remote repository. So your commits might be different to the remote repositories, but assume for a second that we have everything the same except the remote has this one new commit that we don't have, okay? So if we want to get that commit, we can do git pull, and it's going to copy that commit to our local repository, okay? So this is in the scenario where we're working perfectly linearly. We have one branch, we're not merging or anything like that. And Git will just take that commit and it'll sort of put it onto the end of your current sort of working tree, right? And so what's going to happen is it's going to update the head of your tree. So the head of the tree is sort of like the current commit that you're on, okay? So our head before was this green one, and now that we ran git pull, the head is now this yellow one, okay? So you might say, wait, there's a problem. What if I've got something like this, where someone's pushed their changes and I've gone ahead and I've done some more work, right? I've done some work that may or may not like conflict with the work that they've done. And now we want to get pulled, right? But we can't just play their changes on top of ours, right? Because what's going to happen is we're going to get the working directory and it's going to overwrite all of the changes that we made, right? So this is a problem because now we have two different sets of changes and we need to sort of work out which one we want. Now, if we're lucky and we haven't gone ahead and made more changes and made conflicting changes, Git kind of says that's no big deal. We can make a new merging commit that combines both commits, okay? So when you do git pull and you have some extra commits that don't conflict with the remote repository, but you have commits that the remote repository doesn't have, Git can sort of intelligently merge the two commits into a new commit, which is a merge commit, okay? So when you're running git pull and you merge something, you are actually creating a new commit. You're not sort of merging it into your own commit. So a new commit gets made here, right? So the consequence of this is if we go ahead and we do git push, we're going to upload this red commit and we're also going to upload this orange commit, okay? So just like any other commit, this merge commit also has a hash. So if you wanted to reset to this commit or reset to any other commit, we can refer to it by this hash. And I'll go into git reset later. It's a very useful command, but often you won't really have to use it. So the point being is that if we have a situation where our work doesn't conflict with our friend's work in the remote repository, Git will just automatically merge it for us using magic. So two things to know about merging. So the first thing is that the commit will be made automatically only if the two commits in the remote, like between your repository and the remote repository, if they don't conflict at all, right? So if person A is working on one file and person B is working on a completely different file, Git will merge that just fine. But if two people are working on the same code at the same line, then you'll get a merge conflict. I would like to demo this a little bit, but I might do it towards the end because I don't want to get bogged down too much about resolving merge conflicts. The point is that a merge conflict isn't necessarily the end of the world. Basically how it'll work is Git is going to show you the two different changes, one for your local repository and one for the remote repository, and you can delete the one that you don't want, okay? So Git status, we've been using this a lot already, so I'm going to really skim over this. I'm going to give an explanation of the output. So when we run Git status, I hope this is kind of semi-readable, but if it's not, then I can switch to the other terminal. When we run Git status, it's going to tell us the state of our working directory. It's going to tell us the state of the index, and it's going to tell us how many commits we are behind or ahead of the remote repository, okay? So when we have changes that aren't staged for commit, these are changes that are for files that are tracked by Git. In other words, they appear somewhere in the index, but we haven't Git added those changes. So this is when our local files differ from the files in the commit. I think it's kind of self-explanatory. Does that kind of make sense? Does anyone have any questions about using Git status and reading the output of Git status? Cool.
Just a quick question.
Yeah.
What exactly does that mean? Does that mean the current working directory or does it mean?
So head is the current latest commit that you're working on, okay? So you can move the head around. So you can use commands like git reset to change which is the current head commit, which is effectively changing which commit you're presently looking at. So for the moment, I'm going to think of the head as being just the latest commit that you have in your local repository, okay? So a little bit more about, do you have a question?
Yeah, it's like a pointer.
Yeah, exactly. So you can think of the head commit as being a pointer where it points to the hash of the commit that is like the current latest commit. So it's like a pointer in that respect. Rather than having an address, it uses the hash of the commit. So I will get a little bit into that as we get into the next command. But that pretty much comprises all of the really important commands for Git. This is kind of like the basic bread and butter of Git. These 6 commands will pretty much comprise almost everything that you do on the day-to-day when you're working with Git in a professional environment or when you're working at uni. So those 6 are kind of the must-knows. These are really the should-knows. Git branch is probably a little bit more important, but Git checkout and Git reset are also very important. So these are the commands that you'll probably use in, I'd say probably 80 to 90% of all of the repositories that you work with. And this pretty much pertains to resetting to old commits that you've already made, recovering your work, checking out different versions of the repository that you're looking at, and so on. So Git branch, I've said here that Git branch lists branches of code, but you can also make new branches using Git branch. So a branch in Git is like an entirely new version of the repository. And under the hood, what a branch is it's literally just a name for a commit, okay? So if we have a branch in Git, you could have something like master, which is the branch that always exists in every Git repository. That kind of represents the master copy of your code, which is kind of like the live copy. But you can make branches out the wazoo. You can make as many branches as you like, and each branch can you can think of it as essentially a name for a commit, okay? So when we talk about pushing to a branch, what we're doing is we are adding a commit onto the end of the head of that branch, and we are changing the head of the branch to point to the new commit. That probably sounds like a mouthful, but I'm going to make a few branches and I'll show you what I mean. So with Git branch, you can list branches of code. So it's a set of commits diverging from another branch, usually master. And you can think of a branch visually as being like this. So if you use a program like SourceTree, it's going to actually show you branches with a diagram like this. So if you want to learn about how like the branches actually kind of look, if you wanted to visualize them, SourceTree is a great program for that. But imagine for a second we have a new branch called someone's branch, right? And it has diverged from master at this 34A EB9, this gray commit over here, right? So these 2 branches have entirely diverged, and we have 2 different sets of code for both of those branches. So if we ran Git branch here with this kind of setup, where we've got master and someone's branch, and we're currently on master, Git branch will just output a list of all the branches, and that's it. I haven't gone into making branches on the command line because it's usually easier to make them on the website. But I can go through that at the end if people are interested. So yeah, Git branch really just lists all of the branches that are in your repository. Does anyone have any questions about branches? Okay. So why use branches? So branches form one of the many components of like what your usage pattern of Git is. So branches are for when you want to work independently. Like a good practice is to actually have a branch for each person in your team if you're working on an assignment. If you're working at a company, often you'll have a branch for each different feature that you're working on. And then when you're finished working on that feature, you can merge one branch into another, which you can do with Git pull, by the way. So branches are for when you want to work independently and you want to be able to sort of merge that branch back into master later, okay? So pulling from a branch into another branch is basically the same as pulling from a repository into your repository, because you can think of your copy of the repository as a branch that's just on your device, right? And you're merging from a remote branch into your local branch. So when you start working on a new feature, it's best practice to make a new branch. And then merge it when you're finished. So when you're finished working on a feature, you should merge it back into the master branch if you're comfortable that it works. So Git checkout is when we want to switch to a branch. So if we have made a bunch of branches, we're currently on master, and we want to check out the commit that corresponds to some other branch, you can use Git checkout and type the name of the branch, and then your repository will update with the contents of that branch commit, okay? So it will reset your files to the head of the branch. So this is going back to the notion of like a head. So a branch has like its head, which is the latest commit in that branch. And when you do git checkout and then type the name of the branch, what you're doing is you are resetting all of your local files to be the most recent commit in that branch. Okay? Does that kind of make sense? Is anyone totally confused by that and wants like an alternate explanation, a bit of a demo? I'll give a demo, but I can explain it a bit more. Yeah.
But just to confirm, you can do access different branches on your local machine at the same time. You're always like one branch.
That's right. That's right. So when you do git checkout, what you're doing is you are switching your entire repository contents to that branch's most recent commit. Okay. So thus far, with like all this stuff back here, we've been working under the assumption that we had one branch, right? We had the remote repository, which has a master branch, and we have the master branch on our local repository. So now we're getting into more advanced workflows where we have several branches that can diverge from each other. So now the big question is, what happens when I inevitably completely screw my repo up? And it will happen because Git is a confusing beast. But thankfully, Git also has a lot of tools that let us unscrew up our branch, our repo. So Git reset is kind of what it says on the tin. It's the reset button. It lets you go back to a particular commit and continue your work from there. So there are 3 kinds of reset that you can perform. So the first one is you could do just git reset, which is what that does is it resets the index, but not your local files, okay? So if you do git reset and then type nothing, it's going to reset your index to be like your, to the contents of your head commit, okay? So in other words, if I've git added a bunch of stuff and I want to just unadd everything and go back to the state of having like a clean index, I can just do git reset, unstages everything. Git reset -- soft. So this is when you want to reset your local files, but you want to keep all of the changes in the index, okay? So often you'll do this if you want to merge a bunch of commits together. So you want to kind of squash 10 commits into one commit. I can show you that later if you like, if we've got time. But the point is that this resets your local files, but not the index. And then git reset -- hard is the dangerous one. It's the one that you really need to think about before you type it, because this is kind of like a total reset. It's like it resets your local files and the files that you have staged in the index. So it's just like, I've completely screwed up. I just want to go back to a clean slate. I just want to go back to some commit and just work from there. So an important thing about git reset is that even if you reset -- hard, if you've made commits, those commits don't disappear. Commits are kind of like, they're a little bit sacred in Git. You can't, if you do git reset, you're not going to destroy a commit, but you will erase your local changes and the changes in the index, okay? So the golden rule is pretty much if you've committed it, you can generally reset to it. Even if you do reset -- hard and you reset away from a commit, you can still access that old commit as long as you've done git commit -m blah, 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 okay? So if, for example, our head is currently here and I want to, like, I'm sick of this, I want to go back to this, right? I can do git reset and then paste in the the hash for the commit, and it's going to reset all of my local files to that commit. Well, it'll actually reset the index if you do just git reset, right? And it's going to make the head point to that commit now, okay? So if we start making changes now and we make a new commit, we're going to be making a commit from this commit, all right? So it's kind of going to diverge. If I had a whiteboard, I could draw that up for you, but it's all right. So even though we have reset to this other commit, we can still reset again to the old commit that we were on by just saving the name of the hash. And if you want to look at all of the names of the commits that are leading up to the commit you're currently at, you can do git log or git ref log, and that'll show you all the commits that are leading up to your head, and it's going to show you the hashes of those commits, who made them, and the changes that were made. So I'll show that one too, yeah.
So if we reset to like
Yeah.
made a bunch of changes,
Uh-huh.
and then reset back to the green one,
Mm.
and hit merge,
Yep.
would it move all the changes to after the green commit, or like how would it
Yeah.
reconcile those two versions?
So what will happen is, let's say I have reset here and I make some changes now, and it kind of depends what you do from there. If you add all of those changes and then do git reset to the green commit, all of those changes will be gone from the index, but your local files will remain the same. Okay? If I do git reset -- soft, it'll erase the changes in my local files, but my index will still contain the added changes. If I do git reset -- hard, all the changes are gone, like unrecoverably gone. So that's why you need to be careful when you're doing git reset -- hard. But let's assume for a second that you did git reset and you reset to here. If you did git status, you'd see that you have all of the changes still in your files, and then you could git add them again. And then if you did git commit, all of the changes that you added will be added as a new commit on the end of the green commit. Does that kind of make sense? I realize that's like a massive amount of words and like information. Is anyone confused by that or wants me to go over it? Okay, I'm detecting a no.
Just a quick question.
Yeah. I'm going to make them available after. I'll put them on the Facebook event. So this is the last demo. So I'm going to show you a whole bunch of like resetting, making branches, and general Git wizardry. So if I'm on, so you can see I have a file that I'm going to add. So another command I want to showcase is git log. So git log lets us see all of the commits leading to the current head, and it will show you their hashes and the authors and the messages, right? So you can see that we added this, I made a new file commit, and we've got the initial commit as well. And if we were to copy this hash here, hope this works. Oh no, don't do that. Yep. And now if we do git status, we can see that we have reset to that old commit, right? And we have these untracked files because according to that old commit, we didn't have those files at that time, right? And if I go git log, you can see it's only going to show me the previous commit to this one now because we only had 2 commits and we've reset the head, right? So before we had our head kind of like here at this commit, and then we moved it back 1 commit to here. So this new commit still exists and we can still reset to it. But our head is now pointing sort of backwards in the Git history, okay? So this is like, I want to go back to this version, I want to check out the code, I want to make some changes, and I might want to continue my work from there, right? So if I go git reflog, so this is going to show us, this is kind of like the history of the head of your commit. So you can refer to head at 0 as the current head. Head at 1 is the head 1 history step ago, and then head at 2 is the head 2 history steps ago, right? So you can see I git reset from origin/head, which was like the latest commit, and before that I was on like the initial commit. This will make sense if you play around with it. So those are just some extra commands. So now I'm going to go through some common Git paradigms and the ways different companies will use Git. So the first one is release branches. So what you're going to do is you're going to make a branch for each feature and then merge that branch into another branch, which is your release branch, okay? So a release branch is going to aggregate several features into one branch, and that branch can then actually be merged again into the master branch, which should represent like the live copy of the code. For your assignments, this is probably a bit too advanced, but if you're really dedicated, you could try this. Why? It's easier to lump multiple features into one branch. Like if you're the Commonwealth Bank and you're working on the CommBank app and you have like a new payment system coming in and you've got someone else working on some new buttons for your interface and someone else is working on some more backend code or whatever, you could lump all of those features into one branch by merging them into that branch. And then once you're ready to release that whole suite of features and you've tested that they all work together, then you can merge that directly into the master branch. Okay, this is a really common like Git paradigm. In fact, this is probably one of the most common Git sort of like use cases. which is having a feature for a branch for each feature. Another one that's made very famous by Google is monorepository. So basically, it's an idea that sounds kind of insane at face value, but it makes a lot of sense when you think about the use case that Google has, which is, what if you just have one big repository for all of your code, rather than having a repository for each project? So Google is pretty famous for doing this. All of their products are in one gigantic repository that is like millions upon millions of lines of code. And you might think, wow, that's really dumb, Google, but in fact, it makes a lot of sense. So the reason is it makes managing dependencies between projects much easier, because when you do git pull, you're not just getting the changes from your project, you're getting the changes from every project that might interact with your project. So if you imagine somewhere like Google, where you've got like Google Sheets, Google Docs, Google Slides and things like that, where they all integrate with each other, having them all in one repository like this means that all you have to do is git pull, basically, and you'll have all of the changes from all of the different code bases, and you can work with them together. However, if we do git pull, right, what we're going to do is, if we've got a whole bunch of commits that we've made, and we need to aggregate like 50 commits that someone else has made, or like massive amounts of people have made, you're going to have a huge number of commits that get kind of digested into one merge commit. And that's going to make for a very unreadable Git history, because you're going to have one huge commit that merged like 50 different commits together. So to sort of fix that, we have another command called git rebase. So you can use git rebase kind of like as a substitute for git pull. If you do git pull -- rebase, instead of pulling the changes and making a merge commit, it'll do a rebase. So what rebase does is it attaches your local changes to the end of a branch, or like to the end of some incoming commits, right? So I'm going to show you the situation we had before with git merge, but this time I'm going to use git rebase, and you can kind of get an idea for what the difference is. A lot of people like git rebase a lot more than git pull, because it preserves the history of your repository, right? So if we have the remote repository looks like this, and our local repository looks like this, if we do git rebase, we're going to replay that new change, that yellow change, in front of the changes that we made. And this is good because we can see that we have maintained the history of the changes of our branch, right? Rather than making a new commit that merges some other disparate changes. So it's good for maintaining the history of your branch. So that's really it. We've got a bit of Q&A. If anyone has any questions, you can ask them now. Otherwise, please leave feedback. And thanks for coming.